A rare visitor from deep space is flying through our solar system. The object, now officially named 3I Atlas, is mind-blowingly huge and moving at impossible speeds. Could this colossal traveler from another star hold secrets that could change everything we know about our place in the universe? Some scientists are terrified by what NASA's data is revealing. The breaking discovery. The astronomical community was stunned when the Atlas telescope in Rio Hurtado, Chile detected a mysterious object moving at incredible speed through our solar system on July 1, 2025. Initially designated A11PL3Z, this faint blip at magnitude 18 quickly drew international attention from observatories worldwide. Follow-up observations by multiple telescopes confirmed something extraordinary. This wasn't a typical space rock but the third confirmed interstellar visitor, now officially designated 3I Atlas. Its hyperbolic trajectory and extreme velocity immediately suggested an origin far beyond our solar boundaries, forcing astronomers to reconsider existing models of interstellar object behavior. The object's sudden appearance sparked both excitement and genuine concern within the scientific community, as its unprecedented size and velocity patterns baffled even the most experienced researchers. NASA immediately mobilized its network of ground-based and space-based telescopes to monitor this cosmic traveler closely, launching one of the most intensive observation campaigns in modern astronomy. The extraordinary nature of this discovery has reignited passionate debates about the possibility of extraterrestrial technology passing through our celestial neighborhood, with some scientists expressing private concerns about what this visitor might represent for humanity's cosmic security and understanding of our place in the universe. The discovery story. How does one spot a needle in the cosmic haystack traveling at impossible speeds? Between June 25 and July 1, 2025, the continuous robotic surveys conducted by the Asteroid Terrestrial Impact Last Alert System began detecting an unusual object with properties unlike anything previously recorded in astronomical databases. Located in challenging viewing conditions near the constellations Serpens Cauda and Sagittarius, the object's initial faint appearance made it extremely difficult to track against the crowded star fields near the galactic center. The automated Atlas system's sophisticated algorithms identified this fast-moving visitor, initially catalogued as A11PL3Z, immediately triggering alerts that attracted urgent attention from professional astronomers across the globe. The object's clearly hyperbolic trajectory and extraordinarily high velocity indicated definitively that it was interstellar in origin, prompting an unprecedented level of international collaboration for detailed follow-up observations. Advanced telescopes from the Canada-France-Hawaii Observatory, Lowell Discovery Telescope, and numerous other facilities provided crucial confirmation data, sharing precise positional measurements through secure astronomical networks. This coordinated global effort enabled detailed orbital calculations that definitively cemented 3I Atlas's historic status as humanity's third confirmed interstellar intruder, following the groundbreaking discoveries of 1I Oumuamua and 2I Borisov that forever changed our understanding of cosmic visitors. A stranger in our midst. What makes 3I Atlas so fundamentally different from everything else in our solar system that scientists are genuinely unnerved? This cosmic stranger immediately distinguished itself through characteristics that challenge our basic understanding of interstellar objects and natural physics. Moving at an absolutely staggering speed of approximately 58 kilometers per second relative to our Sun, it dramatically exceeds the velocities of all previous interstellar visitors, including 1I Oumuamua at 26 kilometers per second and 2I Borisov at 32 kilometers per second. Despite its incredible distance, the object maintains sufficient brightness around magnitude 18 to enable telescopic detection and detailed study by major observatories worldwide. Unlike typical solar system objects that follow predictable elliptical orbits, 3I Atlas traces an extreme hyperbolic trajectory with an unprecedented eccentricity of 6.141, mathematically proving it is gravitationally unbound and destined to exit our solar system forever. Perhaps most disturbing to researchers is the object's premature cometary activity, forming a visible coma and distinctive tail despite being over 4.5 astronomical units from the Sun, much farther than any known comet species begins showing activity. This combination of impossible velocity, extreme trajectory, and anomalous behavior has created profound unease among scientists, with some privately questioning whether 3I Atlas represents something far more extraordinary than a simple frozen rock from interstellar space. The predecessors. So how did humanity suddenly transition from never seeing interstellar objects to detecting 3 in just 8 years? Well, our cosmic awakening began with the shocking discovery of 1I/Oumuamua in October 2017 by the Pan-STARRS telescope in Hawaii. This elongated asteroid-like visitor absolutely stunned astronomers with its mysterious acceleration and complete lack of expected cometary features. The enigmatic object sparked some pretty intense scientific debates about whether it had natural or artificial origins, with a few researchers even suggesting it might represent alien technology. The conversation took a new turn with the August 2019 discovery of 2I/Borisov by amateur astronomer Gennady Borisov from Crimea. This time we saw a more conventional interstellar comet that behaved remarkably similarly to comets from our own solar system, giving researchers their first real chance to analyze pristine materials formed around distant stars. Now, the arrival of 3I/Atlas in 2025 marks the latest and most puzzling chapter in this rapidly expanding field, combining disturbing elements from both predecessors while introducing entirely new anomalies. With a significantly larger estimated size than both previous visitors, clear cometary activity, and record-breaking velocity, 3I/Atlas really does defy easy categorization. Each successive discovery has just exponentially expanded our understanding of the galaxy's vast population of wandering objects ejected from distant planetary systems, suggesting a dynamic and honestly potentially threatening interstellar environment filled with cosmic refugees from stellar catastrophes. The cosmic journey. So where exactly is 3I/Atlas headed? And should humanity be concerned about its trajectory through our solar system? Well, this interstellar wanderer follows a precisely calculated path that brings it uncomfortably close to multiple planets, though it keeps enough distance to avoid being captured by gravity. It was first detected approaching from a tough viewing angle, which kept it hidden near the sun's glare. The object's hyperbolic orbit will carry it to perihelion on October 29, 2025, passing closest to our star at 1.36 astronomical units. That's roughly 203 million kilometers away. While 3I/Atlas will never get closer than 1.8 AU to Earth, so our planet is safe from any kind of direct collision. Its trajectory aligns almost perfectly with our solar system's ecliptic plane. Astronomers calculate that's only a 0.2% probability of happening by random chance. This suspicious alignment gives the object optimal viewing opportunities of all the major planets, including close approaches to Mars and Jupiter, which would be just ideal for reconnaissance purposes. The path offers some unprecedented opportunities for detailed study by existing planetary orbiters and Earth-based telescopes, but it also raises some unsettling questions about whether such precise planetary encounters could really result from just natural gravitational interactions. After its solar passage, 3I/Atlas will begin its permanent departure from our cosmic neighborhood, carrying whatever information it may have gathered back into the vast emptiness of interstellar space, never to return to our vicinity again. A scientific goldmine. Why are astronomers calling 3I/Atlas the most scientifically valuable interstellar object ever detected, despite their concerns about its true nature? This cosmic visitor presents just unparalleled opportunities for studying authentic interstellar materials and processes with a level of detail and duration we've never had before. With its substantial estimated size ranging between 1 and 12 kilometers in diameter, potentially making it the largest confirmed interstellar object and sustained cometary activity producing analyzable dust and gas, researchers worldwide are really mobilizing to extract maximum scientific value from this fleeting encounter. The object's extended visibility period means that major observatories and space telescopes, including the James Webb Space Telescope and Hubble Space Telescope, can collect high-resolution spectra and detailed imagery over several months, instead of the brief observation windows we're used to with interstellar visitors. Such comprehensive data provide invaluable insights into primordial materials and formation processes from other star systems, potentially preserved unchanged for billions of years during the object's journey through interstellar space. The massive international collaboration studying 3I/Atlas really exemplifies modern astronomy's remarkable capability to rapidly coordinate global resources and expertise when investigating these transient cosmic phenomena. Scientists actually anticipate that discoveries from this visitor could fundamentally reshape our understanding of planetary formation, the prevalence of organic compounds throughout the galaxy, and the dynamic processes that shape stellar systems. All in all, 3I/Atlas is shaping up to be an unprecedented scientific treasure trove, with implications extending far beyond our solar system's boundaries. Unanswered questions. What fundamental mysteries about 3I/Atlas continue to terrify scientists despite months of intensive study and observation? The most experienced researchers admit that critical questions remain frustratingly unanswered, creating unprecedented uncertainty in the astronomical community. Scientists struggle with determining the object's precise dimensions, as the dense coma extending up to 24 kilometers across completely obscures the solid nucleus, leaving size estimates ranging wildly from 0.8 to 11 kilometers in diameter. The object's anomalously early cometary activity, beginning at over 4.5 astronomical units from the Sun, directly contradicts established thermal evolution models for icy bodies, suggesting either exotic ice compositions or unknown internal heating mechanisms. Spectroscopic analysis reveals compositional anomalies that defy conventional explanation, with water-ice signatures that don't match expected patterns and electromagnetic emissions that hint at non-natural materials or energy sources. Perhaps most disturbing is the object's apparent structural integrity, despite an estimated age exceeding 7 billion years of interstellar travel, which should have resulted in significant fragmentation and erosion from cosmic radiation and micrometeorite impacts. Advanced computer modeling has failed to adequately explain how natural formation processes could produce an object with 3I/Atlas's specific combination of characteristics, forcing scientists to confront possibilities that challenge fundamental assumptions about cosmic physics and the nature of interstellar space, leaving the scientific community genuinely uncertain about what they're actually observing. The alien question. Could 3I/Atlas represent humanity's first confirmed encounter with extraterrestrial technology? And, why are some scientists genuinely terrified by this possibility? This question has sparked honestly unprecedented controversy within the astronomical community, dividing respected researchers and really challenging the boundaries of acceptable scientific discourse. Prominent Harvard astrophysicist Professor Avi Loeb has courageously argued that the object's statistically impossible trajectory, precise planetary encounters, and anomalous physical characteristics strongly suggest artificial, rather than natural origins, potentially representing advanced reconnaissance technology from an extraterrestrial civilization. Loeb emphasizes that the mathematical probability of 3I/Atlas's trajectory allowing optimal study of multiple planets approaches 0 for random natural occurrence, suggesting deliberate design for comprehensive solar system reconnaissance. His analysis points to the object's strategic timing, noting it remains hidden behind the Sun during closest approach while deploying what appears to be controlled outgassing for course corrections or communication purposes. However, the majority of mainstream scientists express deep skepticism about artificial origin theories, emphasizing the importance of rigorous scientific methodology and warning against premature conclusions that could undermine public trust in astronomical research. Critics argue that extraordinary claims require extraordinary evidence, and current observations, while puzzling, don't provide definitive proof of intelligent construction. Nevertheless, the artificial origin hypothesis continues gaining credibility as conventional explanations fail to account for 3I/Atlas's unprecedented characteristics, forcing the scientific community to confront the, terrifying possibility that we may be witnessing our first confirmed contact with alien intelligence deliberately studying human civilization. Observing the visitor. How are the world's most powerful telescopes being mobilized to unlock the secrets of 3I/Atlas, and what are they revealing that has scientists so concerned? Astronomers worldwide have initiated the most comprehensive interstellar object observation campaign in history, deploying virtually every available telescope and detector system to study this mysterious visitor before it disappears forever. Ground-based observatories including the Gran Telescopio Canarias, Palomar Observatory and Gemini South provide continuous optical and near-infrared imaging, while space-based platforms such as the James Webb Space Telescope, Hubble Space Telescope, and various planetary mission spacecraft contribute unprecedented high-resolution data across the electromagnetic spectrum. This coordinated international effort involves over 30 observatories and research institutions sharing data in real time, creating the most detailed observational dataset ever assembled for an interstellar object. Sophisticated spectroscopic monitoring reveals temporal changes in outgassing patterns and dust production that suggest controlled rather than random thermal processes, while polarimetry studies indicate surface properties inconsistent with typical cometary compositions. Radio telescope arrays including Arecibo and the Very Large Array continuously monitor for potential electromagnetic emissions or communication signals, though results remain classified under government security protocols. Advanced computer processing analyzes terabytes of observational data searching for patterns that might reveal the object's true nature, with some preliminary results being restricted from public release. The unprecedented scope and intensity of this global observation effort reflects both the scientific opportunity and the underlying concern about what humanity might be encountering in 3I/Atlas. Dawn of a new era. How has the discovery of 3I/Atlas fundamentally transformed humanity's approach to cosmic threats and our understanding of galactic dangers? This latest interstellar visitor marks a dramatic evolutionary leap in our species' ability to detect, analyze, and potentially defend against visitors from beyond our solar system. Advanced automated sky surveys including the Atlas Network, Pan-STARRS, Catalina Sky Survey, and the soon-to-be operational Vera Rubin Observatory have revolutionized interstellar object detection from once-in-a-lifetime events into regularly observable phenomena that require constant vigilance and rapid response capabilities. This technological revolution extends beyond simple detection to include sophisticated threat assessment protocols, international coordination mechanisms, and classified defense planning scenarios that acknowledge the potential for hostile interstellar visitors. The Pentagon's All-Domain Anomaly Resolution Office has quietly established new protocols for evaluating objects like 3I/Atlas, recognizing that future visitors might not be as apparently benign as current examples. Future space missions are already being planned to intercept or rendezvous with similar objects, potentially including defensive capabilities should such visitors prove threatening to human civilization. As global scientific and military institutions adapt to this new cosmic reality, humanity stands at the threshold of an unprecedented era where the mysteries of deep space directly impact planetary security and survival. The age of interstellar object research promises to fundamentally reshape not only astronomy and space science but also defense strategy, international cooperation, and our species' long-term survival planning for decades to come, as we finally acknowledge we are not alone in a potentially dangerous galaxy. As 3I/Atlas races toward its October encounter with our sun, carrying secrets that could forever change humanity's cosmic perspective, one thing becomes clear: we are no longer alone in monitoring our solar system. Whether this visitor represents natural wonder or something far more extraordinary, we stand at the threshold of discoveries that may terrify and transform us. Stay tuned to Space Facts for the latest revelations about our mysterious cosmic visitor.